What we have on the board is a diagram of question 15. And what we can see is that the two points in question 15, one of them's clearly above the line, one of them's clearly below the line. What we had to figure out is how do we actually go about proving this without actually drawing it out, because drawing out costs you time. Okay? So what we're going to do is we're going to go back to the question here. And once again, the full point of this chapter is to show you no other equation other than this one here. Okay, so that means you're going to go to this. And what we're going to do is we're going to experiment with both points, and we're going to see if there's any difference between the two answers. We're expecting them to both be different distances away from the line, as we can see here, different distance away from the line. But is there any difference between being below the line and being above the line? Does it change anything? Let's find out. Okay, so what we get here is the square root of a squared plus b squared on the bottom. Okay, so let's write our lists. A equals 1, B equals 1, C equals minus 120. Okay, for the first part of the question, this one's going to be x1, y1. Okay, and we'll do it in red. Okay, so let's begin. D equals 1 times 100, which is 100. And then it's going to be plus b times 1, which is 1 times 72, which is obviously 72. And then c is minus 120. Close it up. Then on the bottom we're going to get a squared plus b squared, which is going to be it's going to be 1 squared plus 1 squared, right? Now, this one here is d. And what we get is 172 minus 20, which is 52 over root 2. Now just stop there. See the way it's a positive? See the way it's positive 52? Okay? This point in question is above the line. So is it the case that anytime we use this equation, the modulus always turns out to be positive if you're above the line, but negative if you're below the line? So what we're going to do is we're going to check out the negative point next, and then to be sure, what we can do is we can try one more point above the line and one more point below the line, and then we'll know if it works every time, which I'm pretty sure it does. Okay, so we'll find out now. Okay, so let's go back in here. Okay, and we'll do the blue part now. And the blue part is going to be, this one's going to be x1, y1 this time. Okay, so we're going to get d is equal to, now we're going to get 1 times 59 is 59. 1 times 27 is 27. Minus 120, all divided by the square root of 1 squared plus 1 squared. This time it's going to be negative. Can anybody tell me what the number is? 59 plus 20?
Minus 24.
Okay, minus 34 over the square root of 2. I got something for you in a second, right? This means that this one is below the line. They're on opposite sides of the line because this one has a positive value for this part of the equation here. See this part of the equation here? This is the part of the equation that affects if it's positive or negative. Does everybody see that?
Yeah.
So, what we can do next is we can do this. We can write down, if you want to shorten the full thing up, ax1 plus by1 plus c equals 0. Alright? And what we can see next is that I'm going to test 2 points using this formula here. I'm not going to use the full formula. I'm just going to use the part of the formula that determines if it's positive or negative. And we're going to try 2 new points and see if it works. Okay, so what points I'm going to try here is, I'll try this one here, a nice easy one. 0, 80. It's below the line. So what are we expecting? Negative or positive? Negative. Let's find out. 0, 80. Okay? So 0 and 80. And we know that A is, we're basically putting it into this equation here. X plus Y minus 120. Okay? Because A is 1 and B is 1. So, and then we're going to replace in X and Y here. Okay? X1 and Y1. And let's see if it happens. Plus 80 minus 120, 0. We would have got minus 40 for this one. Okay? Minus 40 means it's below the line. So we would have got minus 40 in this position here, which tells us it would be below the line. To hammer the point home, we're just going to go for one more. We'll make it easy. 0, 140. Expecting it to be positive. Let's verify that now. Okay, same deal again. 0, 140, right? Okay, just kill the phone there, please. Okay, and we get 0 plus 140 minus 120. 0. This time it's 20. Now 20 is not equal to 0, but it's bigger than 0. That means you're above the line. What we're going to do next is investigate whether the point minus 20, 10 and 35 minus 40 are on the same side of the line. So look, also what I have to do here, see this formula? Just replace x with minus 20, y with minus 10, or with 10. And if the number turns out to be bigger than 0, it's above the line. Turns out to be smaller than 0, it's below the line. Guys, so what we get here is we get minus 60, minus 20, plus 50 equals 0. That's minus 80 plus 50, it's minus 30. Okay, this one here is clearly below the line. Okay, so what we can do next is we'll enter in the other value and see if it comes above or below the line. Okay, so once again replace x with 35, and now replace y with 40, minus 40 plus 50 equals 0. Once again, remember, what I'm doing is the ax plus by plus c part. I'm replacing in x1 and y1. That's all I'm doing right now. And I get 105 plus 80 plus 50, and we can clearly see this is also above the line, isn't it?
The other was below.
The other one was below, was it?
Yeah, the other was minus 30.
They're not on the same side then. So investigate is the key of the word. Investigate doesn't, if it says show, the answers have to match. If it says investigate, they may or may not match. Okay? So this is 235, which is above the line. So the first one was below, the second one's above. Means they're on different sides of the line. Okay guys, what I'm on to next is somebody asked me to do number 19. Was it 19, was it? And 20? Was it?
19 was on the video.
No, I didn't do 19 in the end. Alright guys, find the value of k if the distance from the point 31 is 6 units. D equals ax1 plus by1 plus c all over the square root of a squared plus b squared. D is 6, a is 3, so it's going to be 3 times 3 plus 4 times minus 1 minus k. All that divided by the square root of 3 squared plus 4 squared. Okay, 6 equals, it's going to be 9 minus 4, so it's going to be 5 minus k all over the square root of so 5, yeah. Cross multiply, 30 equals the modulus of 5 minus k. You have two options. Option 1, square both sides, get a quadratic equation and solve. Option 2, this has to be minus 30 or plus 30 for the modulus to be, for the distance to be 30. So we can say it's 5 minus k equals minus 30, or 5 minus k equals plus 30. Much quicker, what I'll get is k equals minus 25, or k equals 35. Much faster than the quadratic way. Does anybody want me to do the quadratic way as well?
No.
You happy enough? Okay. Now, moving on to the next question. Who got that one now? Out of interest? Okay, so that's pretty good. That's half the class at the end of a chapter question. That's well done. Number 20 now.
You didn't have it.
Oh, so we have 22, right?
21, 22.
21, 22. Okay. There's 22 from yesterday. Okay. So just pause it. Next one is a slope with a line with slope m contains the point 2, 1. Write its equation in the form ax plus by plus c. Okay, has x1 and y1. The equation of the line is y minus y1 equals m bracket x minus x1. Okay, just going to move this over this side of the board because I just want to use 1/2 the board. Okay, y minus 1 equals m into x plus 2. Okay, because it's minus 2. Okay, which is plus 2. Okay, now this is done. Y minus 1 equals mx plus 2m. Okay, we can bring the mx and the 2m to the left. There's two different answers here. Okay, so I'm going to explain what the two different answers are. Right, the first answer would be this: minus mx plus y minus 1 minus 2m. Now guys, you can have a minus version of this and a plus version of this. So in this answer here, a is minus 1, or sorry, minus m. B is c minus 1 minus 2m. There's another answer to this. If I was to multiply this by minus 1, both sides by minus 1, I could have got mx minus 1y plus 1 plus 2m equals 0. In this case, a equals m, b equals minus 1, and c equals 1 plus 2m. Which one do you think is potentially easier to use? Second version, because there's more positives and there's going to be less playing around. Either answer gets you the same one. I'm going to go for this one here. Okay? So I'm going to get rid of my old a plus b plus c here. Okay? Now that I have that done, I'm going to write down the point, hence find the equation of two lines through the point 2 minus 1. So there's a point 2 minus, what's a minus 2 minus? Minus 2, 1. Okay? And this point has two lines going through it, like so. This is your visual aid here. Okay? And then there's a point from the origin. It's the origin that we're talking about. It's 1 unit. So we draw the origin. The origin could be here. Okay, let's say here. It's 0, 0. And the perpendicular distance of both these lines from the origin is what? 1 unit. So that's our diagram. That's what we're talking about. I need to find the equation of these two lines. So once again, we're going to go to our formula, the only formula in this exercise. And then we're going to obviously might drag these down a little, so we'll just arrange. Fine. Okay, let's try that again. Okay, no, ain't working. Okay, let's drag it down a little bit. So yeah, I just want this information beside me for the next part. Otherwise, I'll be jumping up and down. Okay, guys. Now D equals ax1, which is m times. Now what's x1, y1? The origin. Okay. So it's just going to be 0 plus c, which is 2m plus 1, all divided by
0.
M squared. And what's minus 1 squared? Plus 1. Now, might as well just get rid of those zeros there for a second. They're just making life more difficult. Now, what's D? Distance is 1. Square both sides. We're going to get 1 equals 2m plus 1 squared. Same thing as 2m plus 1, 2m plus 1. Oh, not 11, sorry. 2m plus 1, 2m plus 1. And then finally, we're going to have divided by m squared plus 1, because when you square it, the square root disappears. Then what we're going to get is the following. We're going to cross multiply. We're going to get m squared plus 1 on the left. We're going to get 4m squared. Then we're going to get, we're going to get 4m in the middle. or 2m plus 2m, which in turn will give me 4m. And then 1 multiplied by 1, 1. Okay, move everything to the right. And what we get is 3m squared, because we're taking away the other m squared, and then we're taking away the 1. So we're going to get 3m squared plus 4m equals 0. This is not a full quadratic, it's missing the end. It's still called a quadratic. Okay, take out m, and we get 3m plus 4 equals 0. Either the first number equals 0 or the second one does, so we're going to get m equals 0, or 3m plus 4 equals 0. Bring over the 4, divide by 3, m equals minus 4 over 3. We're not done yet. We're not asked for just the slopes, we're asked for the equation of both lines. So what I need to do next is, see this here? This is the version I worked off. So I got to bring this back down with me again, all the way down to the end. Okay, then just going to leave it on its own here for a second. There we go. Now, what I'm going to do is, I'm going to let, anywhere I see m, I put in the number 0, starting off. So what we're going to get is 0 minus 1y plus 1 plus 2m times 0 equals 0. Then we're going to get minus y plus 1 equals 0. This is the same thing as y equals 1. What type of line is y equals 1? Goes straight up. Oh, sorry, straight across. Okay, it goes straight across. Now we're actually going to check our answers at the end of this one using a diagram to see if it actually works. Okay. Now that we have this one done, I brought over the y to the other side. So basically what I did there was this. I just brought the y over the other side and I got 1 equals y, the same thing as y equals 1. Alright, next one. Next one is I got to replace anything I see, replace m with minus 4 over 3. So I can get minus 4 over 3x minus 1y plus 1 plus 2 times minus 4 over 3 equals 0. Minus 4x over 3 minus 1y plus 1 minus 8 over 3. Multiply everything by 3. Minus 4x minus 3y plus 3 minus 8 equals 0. The answer to this one therefore is minus 4x minus 3y minus 5 equals 0. Will someone in the class take down this and remember for me for the next minutes? Y equals 1. This equation here, please take it down for me. The next thing I want you to know is, I want you to tell me what is the point they're equidistant from. And I'm going to set up something for you now. Just going to check the last question's answers via diagram, okay? So the first point we had was 0, 0. That's where the that's the point in which both lines are equidistant from. Can anybody tell me next, what is the point that both lines must go through? 2 minus 2, 1. This point here. Now look at this. Y equals 1. It's a distance of 1 away from the origin, and it passes through the point B. The next thing we're going to do is we're going to enter in the other equation. What's the other equation?
Minus 4 minus 3y minus 5.
Minus 3y minus 5. Are you... Yes, gotcha. It's a distance of 1 this way. Do you see it? Perpendicular distance is 1 this way. This means that both equations is what we're looking for. They're correct, okay? Okay guys.